So the practice problems that I gave you guys was page 49 and 50, 30 through 42, 50, 58, 70, and 88, I believe. Was that, anybody write them down?
I wrote them down, but I didn't get 88.
Okay, was it 50, 58, and 70?
I got 49, 50, 32, 42, 58, 52, 66, 76, and 78.
No, what about 80 and no 88? You got 88? Okay.
Oh, I misheard that.
Okay. All right. Well, I'm gonna call the answers. If there's one that you guys struggled on or need me to go over, star the answer and then let me know and I'll go over it. Okay. So page 49 through 50, 30 through 42 even, I'm gonna do those first. You had to be able to add, subtract, multiply. 30 was x cubed plus 4x squared minus 4x plus 6. X cubed plus 4x squared minus 4x plus 6. 32 was negative x cubed plus 4x squared minus 4x minus 9. Negative x cubed plus 4x squared minus 4x minus 9. 34 was 10x to the 5th plus 3x to the 3rd minus 10x squared plus 6. 10x to the 5th plus 3x to the 3rd minus 10x squared plus 6. 36 was negative 7x squared minus 3x. Negative 7x squared minus 3x. 38 was 8x cubed minus 24x squared minus 48x plus 4. 8x cubed minus 24x squared minus 48x plus 4. 40 was negative 2x squared plus x minus 6. Negative 2x squared plus x minus 6. And then 42 was negative 4y cubed plus 4y squared plus 4y plus 12. Do I need to repeat any of those answers? Anybody at NERSPA? Need to repeat any of those? All right, next one was 58. You could use the FOIL method or the box method to solve it. 58 was 6x squared minus 10x minus 4. 6x squared minus 10x minus 4. 62 was 2x squared minus 3x minus 9. 2x squared minus 3x minus 9. 66 was negative 2x squared plus 7xy minus 3y squared. 2x squared plus 7xy minus 3y squared. That was 66. 76 was 25x squared minus 9. 25x squared minus 9. 78 was 9x squared minus 24x plus 16. 9x squared minus 24x plus 16. And then the last one I gave you guys was 88, and that was a cubed one. And you should have gotten x cubed plus 3x squared plus 3x plus 1. X cubed plus 3x squared plus 3x plus 1. Are there any of those that you guys want me to go over? No? Anybody at NERSPA? Any of those that I need to go over? And send me a chat and let me know. Good, okay. Everybody feel good about those? Okay, well, we are going to go ahead and move on to factoring, which is usually people's least favorite. But the thing is about factoring is you got to know how to factor when we get to later things. So that's why I like to go over it. If you move on to trig, which I think some of you guys will, most of you will, you're going to have to know how to factor for trig too. So I like to go back over it because I don't like to spend a lot of time on it when we get to it. Like you have to know how to factor for quadratics. and then also circles when doing circles too. So let's go back over it. We are going to be doing R5. This is on page 51, starts on page 51 in your book. All right, can anybody remember what is our first step factoring? Anybody remember what the first step is? Can you guys see it okay? How is that looking on the screen here? Zooming in, okay,
It's pretty good.
okay. It looks smaller up there when I'm looking at it, so. Anybody remember it? GCF, good, all right. GCF, so the first thing is you check for a GCF, and what does GCF stand for? Greatest common factor, good. So you always check for that first when you're looking at a problem. All right, so let's say I have 4x plus 12 is my first. I want to factor this, okay? So the GCF is what is the greatest thing that can go into both of these. So what is in common with 4x and 12? This is a two-term polynomial. Can anybody tell me what these have in common? What can go into both of these? That's what the greatest common factor is. 4, okay? So if I bring out a 4, what am I left with? You think about what goes inside. This is like the reverse distributive property. Think about the distributive property as what is this times this. Okay, so think about it. 4 times what is going to give you 4x, x, plus 4 times what's going to give you 12, 3. So we just factor that problem. All right. So that's why we always check for GCF first. And sometimes when you pull out the GCF, you can still factor out the problem that's in the middle. Okay. Let me give you another one. Let's do 3x squared y minus 15xy squared. You guys pull out the GCF for that one. Check for GCF. Factor it using the GCF. Okay, so 3x squared y minus 15xy squared. Factor out the GCF. All right, anybody want to tell me what they got? What can go in? I always look at the coefficients first. So what can go into 3 and 15? 3. And if you have a hard time with your variables, what I tell people to do is just write it out. So you've got an x squared and a y, which means technically it's an x times an x times a y. And then we have an x and a y squared, which is an x and a y and a y. So what do they have in common? They both have an x and they both have a y. So that's going to be what you pull out for that. And then you just see, okay, what times this is going to give you that? We need another x here. And we need a 3 times what's going to give you 15. We need here. We need another y. Or what about the coefficient from 5? So we already have an x and we just need another y. So if you check it, 3 times what's going to give you 3, nothing there. We need an x times x going to give you x squared and a y. And then you know 3 times a -5 will give you -15, x, and then a y, and y make y, xy squared. Have I been muted the whole time? I have? And nobody told me? What did y'all do? But y'all were answering my question, so you had to have been able to hear me. No, okay, y'all, you gotta let me know. All right, hold on, let's see. I'm sharing the screen in just a second once I get it up. Oh, just for like the past minute, okay. Okay, let me go to share window. It won't. All right, hopefully everybody can see this, and I'm pulling up down here at the bottom. Does everybody see this factoring cheat sheet? All right, make sure this is pulling up on your screen. Is that popping up? No. I really hate this. Share screen. Okay, is that popping?
Yes.
Okay. All right, so you guys could print this out. I think it would be helpful to print this out. This is a little cheat sheet. So step 1, always check to pull out GCF. The next thing is you're gonna look at the number of terms. If there's 2 terms, there's some special factoring properties that we're gonna look at. The first one on your screen here, this is called a difference of squares, okay? This is gonna be difference of cubes and sum of cubes. These are your 3 that you really need to know. There's also one, the only one I didn't add up there is, well, perfect squares is not a 2 term, so I can't put that one up there. But I think it would be helpful for you guys to print this out. So if you're at home, print it out so you have it and you can look back at it. All right, I'm gonna stop share. All right, and now y'all can see me and you can hear me. See and hear me. Okay. All right, so let's look at our 2 terms first, and then we'll look at our 3 terms. But always step 1, check for GCF first. I don't know how the sound just quit working. All of a sudden. All right, 2 terms. So when it's 2 terms, the first thing you check for is your special factoring. So difference of squares is one that can be 2 terms. It's the easiest one to check for. If you have 2 terms and it's a perfect square on both of them and there's a minus sign in the middle. So meaning this is a perfect square, so 2 variables that multiply to give you the same thing. And this is a perfect square. So if I took the square root of this, it would give me an actual number, and there's a minus in between. It's a very easy, quick factoring that you guys would just be able to spit out, okay? And it would be x plus 3 and x minus 3. So you take the square root of this, take the square root of that, and it's a plus and a minus. You could also write it as x minus 3 times x plus 3. Then these are equal. Mean the same thing. okay? All right, another example of a difference of squares could be 9x squared minus 100. Can anybody quickly tell me what that factor would be? Well, is 9 a perfect square? Yes. X squared, we know is a perfect square. Is 100 a perfect squared? Yes. Well, let's think about our perfect square numbers, okay? I tried to do this with my kid the other day. All right, 2 times 2, 1 would be 1. 3 times 3 is 9. 4 times 4 is 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64. 9 times 9, 81. 10 times 10, 100. 11 times 11 is, what is that, 121? I forgot my 12 times 12, 144. Is that right? 1, 1, 0, 1, 1, 121. Yeah, look at me. All right. Those are the most common ones. Okay. So 9x squared is going to break up into a 3 and an x. 100 is going to break up into a 10 and a 10. We got a plus and a minus. Everybody got it? Again, these are ones y'all should look at and say, oh, that's a difference of squares. Factor it quickly. All right, let's get one more. What about that one? Factor that one. All right, so x squared is a perfect squared, y squared is a perfect squared. There's a minus here, and then 64 is a perfect square. So I know you can break this up. What is going to be our first? X, y, plus, minus 8. And I forgot my x, y here. Everybody got it? Now you could also do difference of 2 squares. But really, you just treat it the same way. You don't really have to remember that. So like when I say 2 squares, I mean like x to the 4th minus 100. Okay, think about this. This is still a perfect square. If you take the square root of 4, it's going to give you a 2, right? So when we break this up, watch what happens. This becomes a 2 and this becomes a 2. And then you have your plus 10 minus 10. Then you check, can I do it further? Is this a difference of squares? You could break it out further, but 10 is not a perfect square, so we can't. But if there was a number there that you could keep going. Okay, so this is technically a difference of 2 squares, but you treat it the same way. Questions on this? So if you had 2 terms, you need to check to see if it's a difference of squares. The next one that we're going to talk about is difference of 2 cubes, and I kind of already done this when we were multiplying, but that's going to be the next one that we're going to look at. All right, so let's look at our example. X cubed minus 1. So notice here we have 2 terms. All right, when there's a minus, remember the form is always going to be a minus and then a plus plus. Okay, if you guys remembered when we did it the other day, it was x cubed minus a cubed, and then it was x minus a, and then it was an x squared plus xa plus a squared. This is the form. This is the math form, okay? And I told you guys, you're just gonna have to kind of memorize this, the symbols, anyway. So when you have a difference of cubes, it's always gonna be a minus first and then a plus plus. When it's a sum of cubes, it's gonna be a plus and then a minus plus. Right here. Yeah, I was second to write that down. So when I look at filling this in, the first thing that goes in here, you take the cube root of x cubed. Okay, what would be the cube root of x cubed? Does anybody remember what happens if you cube a cube root? What happens to it? If I square a square root, what happens? Anybody know? It cancels. Well, this should be x squared, yeah. They cancel each other out. So the same thing for this one, okay? So this becomes x. So if I cube root that, it becomes x. What's the cube root of 1? Okay, and then to get the numbers that go in here, you square the first term, you square the last term, 1 squared is 1, and then you multiply these two numbers. Then I just factored it. Okay, let's do another one. Let's do x cubed. I'm gonna do a cube now. X cubed plus 8. All right, so this is a sum of cubes. This one. Can I still see that? Sum of cubes. This was a difference of cubes. Notice the difference here. There's a minus on this one. There's a plus. These are still two terms. So again, how do I tell what's the sum of cubes? There's a plus. This is a cubed. And it's 8 a cube. Is there a number that multiplies 3 times as the same that gives me 8? Anybody know what the cube root of 8 is? Is 8 a cube? Yes, it is 2, okay? So I look at this, and here's my form. It's gonna be a plus, minus, plus in my symbols. Sum of cubes, plus, minus, plus. And then you do the same process you did with the difference. You take the cube root of x, which is gonna be x. You take the cube root of 8, which is going to be 2. So I fill that one in. And now I square the first term. I square 2, which would be what? 2 times 2, which is 4. So go there. And then you multiply these two numbers. I just factored that one. And this is on your sheet, the little cheat sheet. And I know it's not the easiest to remember, but it is something that I think would be helpful for you guys to memorize. So these are the pretty much the options for two terms factoring. Check to see if there's GCF, check to see if there's difference of cubes, sum of cubes, or difference of squares. Those are the three special product ones to check for. Questions on this? All right, so we're gonna go ahead and move to factoring trinomials, which is gonna be 3 terms. So looking at 3 terms, we're going to look at the leading coefficient. If the leading coefficient, when I say the leading coefficient, I mean the number that's in front of your x squared or your y squared or whatever your variable is. If your leading coefficient is 1, then you can just do the guess and check method. Okay, so if leading coefficient is just 1, you can use the guess and check. If leading coefficient is one, use this and check. So again, these are three terms. So when I say guess and check, you always take the last term and you want to factor the last term so that it adds to give you the middle term. Okay, so think about 6. What are two factors that multiply to give you 6, but add to give you 5? 3 and 2. And you have to look at the signs. So make sure you look at the signs. So think about it. 3 times 2 is going to give you 6. And then 3 plus 2 is going to equal 5. So you want it to multiply to give you the last term, add to give you the middle term. So if you need to write that down, write it down. So I'll write it over here. So you're going to take last term, find multiples or find numbers that multiply to give last term, but add to give middle term. Does that make sense? So again, you want to find two numbers that multiply to give you the last term, but add to give you the middle term. So what I can do, I don't have to do the reverse box or anything like that. I can just come up with my two factors. It's going to be x plus 3, x plus 2. If I checked it, it would be correct. If I did the box, watch. X plus 3, x plus 2, x squared, 3x, 2x, 6. Or you could do your FOIL, x times x is x squared, 2x, 3x, 6. Okay? So this is easy with the guess and check method. It's easy when this number is 1. Okay? If there's a number here, you're not going to be able to do this. Okay? You're going to have to do something else. Grouping or reverse box. So you guys ready to try a couple of examples? Let's do all right, you guys do those two. X squared minus 6x plus 8, and then x squared minus x minus 12. All right, so again, I look at the last term. I want two numbers that multiply to give you 8, but add to give you -6. Anybody know what those would be? What would be the two numbers? 4 and 2. Now think about what sign they're gonna have to be. If I want them to give you -6, these are gonna either have to be both positive or both negative. So which one is it gonna have to be? So -4 times -2 gives you a +8. -4 plus -2 gives you a -6. So my factor is gonna be x minus 4 times x minus 2. Everybody at NERSPA, did you guys get that? Hopefully everybody can hear me. Okay. This one, I want two numbers that multiply to give me -12, but add to give me -1. This is understood as a -1 here. So think about our numbers, our factors for -12. You could do -12 and 1, that's not gonna give me 1. You could do 6 and 2, that's not gonna give me 1. You could do 4 and 3. Yep, so -4 and 3, -4 and 3, let's check that. -4 times 3 works. And then -4 plus 3 is going to give you the -1. Okay, so this becomes x minus 4 times x plus 3. Everybody get that? Just give me a thumbs up. Thumbs up. So I know you guys are paying attention. Thank you. All right, we're ready to move on to when it gets a little bit more complicated. If for 3 terms, if the coefficient is not 1, then you have to do an extra step. Okay, and this leads us into 4 terms also. So if the leading coefficient is greater than 1, then what you're going to have to do is you're going to have to multiply the first term times the last term. All right, so if leading coefficient is greater than 1, then multiply last term by first term. Find the factors. And then they also still must add to the middle term. Again, this is all in that factoring cheat sheet. So if you don't want to write all this down, you want to. Okay, so example of this one. Maybe I should do 4 terms first. We'll get to it. All right, 2x squared plus 5x plus 3. Here's an example. So notice again, this coefficient in the front is greater than 1. So I'm going to take the last term and I'm going to multiply it by the first term. That's going to give me 6, right? So I want 2 numbers now that multiply to give me 6, but add to give me the middle term 5. So what we're going to do is you're not going to just be able to find these 2 numbers and make a factor. You're going to have to actually do a little bit more work. So think about it. What's it going to be? All right, it could be 6 and 1, but one of these is going to have to be negative. So then that would work. So what else? 3 and 2. That would work, right? So that means now I'm going to create 4 terms from this. This will break up into a 2x and a 3x. So now I have 2x squared plus 2x plus 3x plus 3. I have 4 terms now. From this is where we get this. So you can either factor by grouping. Have you guys heard of that before? Or you could do the reverse box method. Now, I'm sure Mr. Whitehurst probably just did factor by grouping. He didn't do the reverse box because you didn't learn the box method, right? But it's just another way to keep it organized. If you're going to do factor by grouping, and again, this turns into a 4 term, so there's a section on that cheat sheet that has 4 terms. Factor by grouping, you're literally just going to group 2 of these, 2 and 2, and you want to pull out the GCF on both of them, okay? So let's say I'm gonna group the first two and I'm gonna group the second two. I look at these two and I say, okay, what is the GCF of this? The goal is to get the same thing in your parentheses, and then you're gonna pull out something. So what do these two have in common? They both have a 2 and they both have an X. And what's left over goes inside the parentheses. So 2X times, what's gonna go here, X, plus 2X times what's gonna give you 2X? A 1, okay? So I just factored that part. I pulled out my 2X, and if you check it, 2X times X is gonna give you 2X squared. 2X times 1 is gonna give you 2X, okay? Same process over here. The goal is you wanna have the same thing here as what you get over here, okay? So 3X and a 3, what do these two have in common? I'm gonna pull out a 3, and that's gonna be the only thing I can pull out. 3 times what's gonna give you 3X and X. 3 times what's gonna give you 3 and 1. Voila, these are the same. So that's gonna be one of your factors. So X plus 1 is one of them. And then I take the leftovers and make my other factor, 2X plus 3. This is called factor by grouping. Okay, that's one way to do it. The other way is to do the reverse box method. Remember I showed y'all how to multiply using the box method? The reverse box method is we fill in the inside this time and we pull out the outside to get your factors. So we put all 4 of these terms in here, 2X squared, 2X, 3X, and a 3, just like that. It doesn't matter, you could have put 3X here and 2X here, it doesn't matter the order. As long as you put the sign with it, okay? So these are positive, so I'm leaving them like this. So what do these two have in common? I pull up here, and then these two, what do these two have in common? I pull up here. What do these two have in common? I pull out here. And what do these two have in common? I pull out here. And what's on the outside is your factor. Remember before, I did something like this, and I put X plus 1, 2X plus 1 here. And I filled in the middle. Y'all remember that? So this time we're working backwards. So what did 2X squared and 3X have in common? X. What about 2X and 3? Anything? Just I would put 0. A 1. Okay, because 1 can go into both of those, right? What about a 2X squared and a 2X? A 2 and X, and then a 3X and a 3, be a 3. And look what we got. I got an X and a positive 1. It's gonna be X plus 1. I got a 2X and a positive 3. That's gonna be 2X plus 3. So I don't care which way y'all do it. If you already learned it using this way, keep doing the grouping. If you like the reverse box, use the reverse box. Yeah.
2X squared.
So I got that from, remember our 2 numbers that we did? So it was what, 2 times 3 is 6. Remember you told me it was a 2 and a 3, right? So these 2 numbers are what make up. The 5X is what breaks up into the 2 and the 3. You just have to put an X with it. That makes sense? So we're changing it into a 4 term. These are our factors and the 5 breaks up. We're gonna do a couple more of these. Questions? Add an X with it. Because it's like it's breaking the 5 up. And that's how you get your factors. That's the extra step that we didn't have before. All right, let's do another one. Let's do 3X squared plus 4X plus 1. No, I wrote that wrong. 3X squared minus 2X. I wanted it to be backable, so 2X minus 8. You know, some things aren't factorable. If you break it up and you can't find 2 numbers that multiply to give you that number, but add to give you the other number, you're gonna put not factorable, okay? So I wanted to make it so it is factorable. The one I wrote was Vanderbilt. Vicksburg -2x, -8, but we'll do another one after that one. All right, go ahead and try it. Remember, multiply the last term by the first term. Find two numbers that multiply to give you that number, but add to give you the middle term. Then break up into 4 terms and then go from there. I just realized y'all have all been answering and I just couldn't see it. Wow. Okay, y'all making me feel better. Roll down. I'm also recording this, so if there's something like you guys want to go back and look at, I didn't record the last one, but I'm trying to remember to record every time. I will link, I'm gonna try to, every lesson, I'm gonna try to record and then go back and link it in Moodle, so that way if y'all want to rewatch it or whatever, or you're not here for some reason, you can go back and watch it. All right, y'all done? Y'all still working? Okay. All right, so first thing, well, first we check for GCF. I have been doing that, but we should. There's nothing that can go into 3, 2, and 8, and they don't all have the same variable, so there's no GCF. So then I say, okay, I'm gonna multiply -8 times 3. That's gonna give you a -24, right? So I want two numbers that multiply to give me -24, but add to give me -2. And what those two numbers are gonna end up breaking this -2 up into 2 terms. Okay, so that makes our 4 terms. So let's think about our factors. Anybody from NERS want to give me these? What are two numbers that multiply to give me -24, but add to give me -2? Somebody from NERSBA. Or Abigail. All right, next, -6 and 4. Thank you, Latrell. -6 and 4. -6 times 4 gives you a -24. -6 plus 4 gives me a -2. Perfect. So these terms are going to go up here, -6x and not negative, 4x, positive 4x. So -6x, positive 4x. Notice if you combine them, they should give you -2, right? So we're making 4 terms. I'm rewriting them, so I've got 4 terms to make this full. Okay, this is a plus. These two should add to give you the middle term. So I'm just rewriting the problem. We're not making a whole new equation. We're just rewriting it with 4 terms. Now, we can either do grouping or we could do box. Which one do you guys like better? Doesn't matter. Okay, box. All right, here's the box. I'm gonna put 3x squared first. I'm gonna do negative 6x. I'm gonna do positive 4x. I'm gonna do a negative 8. Now with the box, you do need to be careful with the signs. Notice how these both have a negative here. So you're gonna pull your negative out up here at the top. Does that make sense? Because both of these have negative, so the negative's gonna come out here. So when I check these two, what do 3x squared and 4x have in common? Buddy, 3x squared and 4x. X. All right, what do negative 6x and negative 8 have in common? What can go into 6 and 8? 2. And I already pulled out my negative, so I'm good on that. What about 3x squared and negative 6x? I already pulled out my negative, so I don't have to worry about my sign anymore. Good. 3 and x. I'm seeing what you guys are posting. Okay. 4x and negative 8. 4. And again, I already pulled out my negative. The nice thing about this is you can check your answer really quickly. 3x times x is going to give you 3x squared. 3x times negative 2 is going to give you a negative 6x. 4 times x is going to give you a 4x. And 4 times negative 2 is going to give you a negative 8. If you check it and it's not right, then you messed up somewhere. Okay. So my factor becomes x minus 2 and 3x plus 4. Now you could still do this with grouping. I'll do that real quick too, just to go back over it. I'm going to group the first two and the last two. You don't always have to do that, but most of the time it works when you do that. What do 3x squared and negative 6x have in common? They both have a 3 and an x. And what do I have left over? I have an x minus 2. Okay, so I just did that one. And now I'm going to do 4x minus 8. They both have a 4 in common. I'm left with an x minus 2. So again, for your grouping, you would pull down the x minus 2. And then you have that 3x and the 4 left over here. And so that becomes 3x plus 4. I don't care which way I do it. I like this way just because it's easier to kind of see it. Questions on this? People struggle with this, I'll be honest with you. Like, when I taught high school, factoring was like the thing that people just, and you lose it when you don't use it, obviously. I mean, who factors out in the real world every day? Not many people do. So, we're gonna stop here because I'm not gonna keep going. We're gonna work on some more of these. There's like the perfect square factorials, and I am gonna show you completing the square also. Tonight, I'm not gonna give you any practice on this because I want you guys to make sure you do your quiz that's due tonight if you haven't done it. So go back and make sure you do the R4 quiz from last week. And then if you haven't done the intro discussion, do that because it's a grade. And a lot of people don't do the discussions, and that's the easy. Why not? It takes you like 2 minutes to do it. If you have not already done the mandatory enrollment assignment, go ahead and do that. Although I have already marked you guys present if you've attended, but I do like you to go ahead and do that too. So questions, anybody have a question? R4 quiz, intro discussion. So this is all under week 1 on Moodle, and mandatory enrollment assignment. Everybody good? All right. I'll see you guys on Thursday.